Alright, so now we're going to be looking at this app and manipulating the app to see more about this equation here. So FB is equal to qvB sine theta. Now remember, if the particle's coming in at 90 degrees to the field, then sine of 90 is equal to 1. So pretty much this is going, that sine theta is going to be gone. So that's what the relationship is there. Now because I'm measuring the effect of the radius, and we know that FB is equal to FC, then let's do qvB equals mv squared on r. The v cancels with that v, which means we have qb equals m on r. Let's times by r, so we get qrb over m, and we divide by b, m over b. Okay, I've lost the velocity. Okay, that's better. Okay, so what we're saying here is that this relationship here is equal to that over there. So Q and R, we would expect Q and R, therefore, if this is not changed, if the mass doesn't change, its velocity doesn't change, and the magnetic field strength doesn't change, then we would expect that as you increase the value of Q, that means the radius should decrease. Okay, let's see if that's the case. So let's make the charge 1. Okay, press start, and then we have it curving downwards like that. Okay, let's now increase the charge, and according to this equation, then the radius should decrease. So let's have a look at that and see if we get a smaller radii. Yes, we do. So we can see that knowing this equation here, and making these two equal to each other, I can now manipulate and relate the radius with the charge. Okay, and this sort of connection is really important, because later on in the course, when we talk about how the structure of matter was worked out, and the charge of electrons and the mass to charge ratio comes back to these sort of equations. So these are very important. So that's the equation. Let's do a question on it. Okay, so here we go. An electron passes through a uniform magnetic field at right angles to the direction of the field. Okay, so straight away you'd be saying, therefore, sine theta equals 1, or sine of 90 equals 1. The velocity of the electron is this, so let's write the velocity in. The velocity is 4.0 times 10 to the 6 meters per second. And the strength of the field, right, strength of the field is 0.5 Teslas. What is the magnitude of the force? Okay, so we know that FB is equal to qvB sine theta. We just said that the sine theta is 1, so Q is the charge on an electron. So to find the charge on an electron, of course, you go to your data sheet. Okay, and your data sheet charge of an electron is minus 1.602 times 10 to the minus 19 coulombs. We then, of course, put the velocity in, which is 4.0 times 10 to the 6. Then we put in the magnetic, the magnetic field, 0.5. And when we times all that together, what do we get? Okay, 1.602 to the minus 19 times 4 power of 6 times 0.5, and we get 3.2 times 10 to the minus 13 newtons. Now of course that's just the charge, which is minus. I'm not going to include the minus there because you can't have a minus force. Okay, so that's just telling us the charge on the electron. Okay, so that is the force experienced by that electron. So I'll leave that video there. Please make sure that you check out all the study bite videos after this. I'm going to make quite a few of them to go through questions that the HSC has gone through that examine these concepts that we've just covered in the last 4 or 5 videos, because the way in which they ask them and the way that you can manipulate equations, etc., can be a bit tricky. So let's make some questions and talk about it and get our heads around this section of the syllabus. See you in those videos. Alright, before we go to the next video, I want you to check out more courses that we have here on our YouTube channel, which are just small snippets from the actual bigger courses that we have on the flipteacher.com. Of course, with all of our courses, we try to incorporate practical sessions. We have study cards, we have posters that you can print off and stick around your room and do a lot more. We have up to 68 or more videos per course. That's like 9 to 10 hours of material that really delve deep into the syllabus and looking at essential content, skills, mathematical manipulations, and a lot more. So if you like that, go over to flipteacher.com and check it all out, and I'll see you in the videos.